And I'm going to make you the host. Let me go to the participants. Let me find you. Here you are. Um, make host. Okay, you're the host now. You're on, Melissa. Okay?
Okay.
Okay. All right, I want to enlarge this. Okay. All right. I'm going to give you like about 2 more minutes to do these two problems. Morning. Okay, I think we can get started. Let's look at number one. It's a factoring. All they're asking me is to factor. Does anybody want to tell me what they think I should do first? Any hints as to how I should handle this?
Professor, I think you should put positive, I think you should put 4x squared.
What do we have to do first?
So we're gonna try to find out about the negative 16x in the center.
Yeah, but what do we have to do first with this 4 and this 9?
Okay, you gotta bring the, let me see.
Remember we call it the AC method because
Right.
So what is AC? That's what we have to figure out.
4 times 9,
Right.
negative 9.
It's 4 times negative 9, so it's negative 36. Okay. Now we have to work with that negative 16. What does the negative tell us? What do we know about the signs?
That the bigger number will be negative.
And the other number is going to have to be
A positive.
positive. In other words, we're going to have a negative number and a positive number. And we also know that since the middle is negative, the larger number is going to be the negative. Okay. Well, what numbers are you going to pick?
I'm gonna pick 2 and 18.
Perfect. She knows the numbers have to multiply to 36. She knows they have to subtract because this is a minus to 16. It has to be 2 and 18. And she's going to make the 18 the negative because that's a larger number and the 2 the positive. And of course, you're going to put x's next to each of them. And what are you going to do with this 4x squared?
Bring it down.
Okay, I'm just erasing this so I have a little.
Bond with me, some on there? Bond with me.
And what am I going to do with the negative 9?
You're gonna add the negative 9 at the end.
Mr. Stereo.
I think we have to mute people. Everybody mute yourself, please. Okay, and so now we have 4 terms, so we're doing grouping, right? What
Right.
did you find as a common factor in your first group?
So it's gonna be 2x
X.
And,
and 2x plus 1.
wait, plus 1, 2x and
Oh. Sorry, 2x plus 8 plus 6.
how much is 2 into negative 18?
9, I'm sorry.
Right, so it's gonna be negative 9. Okay, what about your second group? Obviously gonna be plus because that's plus. What's your common factor there?
It's
You don't
2.
have any, so you're gonna use 1.
Okay, so you're gonna put 1 out here and then you're gonna get the 2x minus 9.
Yeah, that's what I got.
Okay, and then your final answer becomes,
It comes 2x plus 1 and 2x negative 9.
perfect. Very good. Good for you, Devonna.
Okay.
Notice you could have put the 2x minus 9 first and the 2x plus 1 second. The order in which you write the 2 parentheses doesn't matter. Just make sure you didn't write a negative 9 and a plus 1. You always have to remember that the middle sign tells you what the sign of the larger number is. That was excellent. Okay, does somebody want to take me through the steps on number 2? This was an equation because it said solve and it has an equal sign. What should my first step be in that? What should, does anybody have any idea? Did Jennifer get in, by the way?
Yeah, I'm here.
Oh, okay, great. What should I do here? What's my first step? What kind of an equation is it?
Is it negative 12?
You gotta mute yourself. You gotta, please mute yourselves. Okay. What do I do when I have an equation? What kind of an equation is it?
Is it a quadratic equation?
Yes, it is a quadratic equation. How do you know that, Stacy?
Because they have the second power. It's
Right,
the
you have
very
an
second
exponent.
power.
You have an exponent of 2. So what do you do in that case, Stacia?
Guess you're gonna bring all your numbers to one side and equal it to 0.
Right. So we obviously want to get, it looks like, now hint. This is just a hint. You don't have to do it this way, but it's just a hint. You know, sometimes it makes more sense to bring things to the right than to the left. How are you going to know which side to bring it to if you have a lot of things on both sides? So it's always easier to figure out your final answer if the x squared term is positive. So if you look for your x squared term and you look for, if it's positive, you want to bring everything to that side. If it's negative, you want to bring everything to the other side because you want it all depends on the x squared. It doesn't matter if the x is positive or negative or the number, but your x squared term, if you want to do it by factoring or even by using the formula, you want your x squared term to be positive. It's just much easier to work with. Okay, so we're going to bring everything to this side because here's where my x squared is positive. So I'm going to subtract the 2x. I'm going to bring this 2x to the other side. I'm going to bring it, put it under here under the 4x under the like terms. And I'm going to subtract the 12. Or if you wanted to, you could just use transposition. So you end up with 5x squared Then we have positive 4x and a negative 2x, which gives me a positive 2x. And plus 12 and negative 12 is 0, so I don't have to put that down. And this canceled out, and this canceled out, so this is what I was left with. At least it looks a lot simpler. I don't have all those terms. What's different about this than a regular quadratic? The fact that we only have two terms. We usually have a trinomial, and here we only have a binomial. But it doesn't matter. We do the same process. We have to factor. What kind of factoring can you do? Anybody see any kind of factoring that could be done here? What's the first type of factoring we always look for?
This is LCM. It's common factor.
Are we having trouble with the internet again? Okay, I couldn't hear what you were saying, Stacia, but what we always look for is a common factor, no matter what. Right, thank you, Cheryl. Whatever factoring we're going to do, the first step is find that common factor, if there is one. And in this case, there is, because, well, there's no number, but this one is an x squared and this is an x. So x is a common factor and I can put it on the outside. So let's see what we get. X into 5x squared gives me 5x. And x into 2x, the x's cancel out. I'm just left with 2. That equals 0. And after we've done our factoring, then we separate. Now, in this case, we don't have two parentheses because this is only a plain x. You don't have to put a parentheses, but it's equivalent. You do set it equal to 0. So one answer becomes x equal to 0. And you put the other factor, the 5x plus 2 equal to 0. And this one you have to solve. First, bring the 2 to the other side, which will give you 5x equal negative 2. And then you want to find out what x is, so you have to divide by 5. So here are my two answers. One answer is 0, and one answer is negative 2/5. So this looked really, really hard when we started out because it had so many terms in it. But it turned out to be a simple factoring because it was just a common factor. So that's how we solve. Great, Stacy. I see you put the same answers that I put on the board. Okay, so again, until here is what is on the midterm. What I'm going to be starting today is from chapter 5. Chapter 5 is not on the midterm. We're just going to be continuing to go on with our studies. Again, what we learn in chapter 5 can be helpful. At the end of the period, the last half hour, again, I will spend some time. Again, if anybody has a specific type of problem or a specific problem that they're running into problems with, please bring it up at the end of the period so we can review it with the whole class.
Don't erase the bottom.
Oh, I'm sorry. I always do this. I'm sorry. I'm gonna erase till here. That's all. Thank you for telling me. Okay. So I think I mentioned, yes, on Tuesday, that the next chapter we're dealing with, chapter 5, is called Rational Expressions and Equations. And the word rational contains as a root word ratio. And the word ratio, another word for ratio is fractions. So when they talk about rational expressions or rational equations, all we're talking about is fractions in equations, fractions in algebraic expressions. And all the things that you know how to do with regular fractions, you can do with these rational expressions, these algebraic fractions. In other words, one of the first things that you probably learned how to do with a fraction is something called reducing the fraction, making it simpler. We're going to learn how to, I'm going to remind you how to do each of these things in regular numbers, going back to 4th and 5th and 6th grade. And then I'm going to show you how it applies to algebra. So we can reduce fractions, we can multiply, divide fractions, we can add and subtract fractions. And what's interesting is we're going to do multiplying and dividing before we do adding and subtracting, because actually multiplying and dividing is easier. And once we know how to add, subtract, multiply, divide fractions, then we're going to talk about how do we deal with fractions in equations when we have pretty difficult equations. Is there a way? And I sort of led into it the other day, but I'm going to come back and do it really very slowly and completely, because I know people don't like working with fractions, but it's something we have to do, and we're going to try and do it to make it as easy as possible. Can I erase the bottom now?
Yeah, go ahead.
Okay, thanks. So fractions are interesting in terms of there are many different versions of the same fraction. For example, if I have the fraction 1/2, I could also call it 4/8, or I could call it 100/200. When we're talking about just plain numbers that are not fractions, what we call integers, there's only one way of writing it. The integer 25 can only be written as 25. But if I want to write it as a fraction, I could write it as 25/1 or 50/2. So when I get to fractions, there are a number of the same fraction can be written in multiple ways. And the problem with that is that when we try to compare, let's say, answers, let's say you come out with an answer that says 1/2, and I come out with an answer that says 5/10. We think we have totally different answers, but actually these two numbers, these two fractions are identical. They're not identical, but they are equal. Okay, so what we very often do is the process called reducing or simplifying a fraction, getting it into its simplest form so that if everybody gets it into the simplest form, then everybody will have the same answer. So if I have something like 5/10, the way we get this into simplest form, the way we reduce it is we try and find a common factor in both the numerator and denominator. Is there a number that goes into both the numerator and the denominator? If there's more than one, take the biggest one you can see. In this case, I see that I can divide both the numerator and denominator by 5. And if I do 5 divided by 5, I get 1. And if I do 10 divided by 5, I get 2. So that 5 over 10 is equivalent. It's equal to the fraction 1/2. The reduced form of 5 over 10 is 1/2. What about something like 42 over 63? Obviously, 5 over 10 was a lot easier. What makes sense is to try to factor your numerator and your denominator, and then see if there's anything like in both of them. So what do we see 42? What does 42 multiply by? What can we multiply 42 by? What gives me 42? What are the factors of 42? Anybody?
21 times 2.
21 and 2, that's one way. Oh, you want to do 21 and times 2? Okay. We could have done, there are a number of ways we doing it. She has suggested I break up the 42 into 21 times 2. What about the 63? Can you think of any factors of 63?
Nine and 5.
21 times 3.
21 and 3, 9 and 5, 9 times 5 is 45. 9 times 6 is 63.
9 and 6. That's what I.
Okay, but she said 21 times 3. And actually, I like that better because then I see that there's a common factor of 21 in both the numerator and the denominator. I can divide out the 21 from both the numerator and denominator. In other words, cancel out the 21, and I get 2 over 3 as my answer in simplest form. So basically, when we want to reduce fractions, what we want to do is see if we can find a common factor in both the numerator and the denominator that can be canceled out. And listen to that term, a common factor. Remember, we were talking about why we did this whole chapter on factoring. Basically, chapter 4, aside from doing a little bit of adding and subtracting and multiplying, the chapter really concentrated on factoring of algebraic expressions. And we said one of the reasons we do factoring is because we can solve quadratic equations by factoring. Well, another reason we do factoring is because when we're going to get to our algebraic fractions, our rational expressions, we're going to want to reduce them by finding a common factor of the numerator and denominator. And again, we're going to have to know how to factor in order to find those common factors. So I'm going to go do this in 2 steps. I'm going to start out with expressions, algebraic fractions that are all monomials. In other words, let's say I have something like this. Ten x squared y cubed over 15 x fourth y. Okay, this is an algebraic, a rational expression. We'll know it's just a fraction that has x's and y's or any kind of letters in them. And we want to reduce it. And my numerator and my denominator are both monomials. There's no pluses or minus in between any of the terms or letters or numbers. So the way we do that is we take each number and letter separately and try to reduce. First, I look at the 10 and the 15, and I think, is there any number that goes into both 10 and 15? Again, if I can think of two numbers that work, I pick the bigger one. I think everybody will see that 5 works.
Five. Mhm.
So 10 divided by 5 will leave me 2. 15 divided by 5 will leave me 3. Now, make sure you do this neatly because this can get pretty messy because there's so many things going on. So leave yourself enough space. If you try to crowd it, you're going to mess up what's on top and what's been crossed out, what's not. That's just a practical suggestion. Then you go to the next variable, which is an x, and I have an x squared and an x fourth. The common factor between the x squared and x fourth is the x squared. We know that the lower exponent is always the common factor. So here's the easiest way to do it. Cross out, we're going to divide the top and the and bottom both by x squared. Now I know when I divide the x squared by x squared, I just get 1. In other words, cancel out the lower exponent, the x squared, and subtract that exponent. 4 minus 2 gives me 2. So on the bottom, I get x squared. Again, let me repeat. Since there are x's on both the top and the bottom, the easiest way to handle this is to cross out the lower exponent and subtract that lower exponent from the higher exponent. Notice I left the x squared that I was left with remains in the denominator because that's where the higher exponent was. Then I go to the y's. I have a y to the third, and this is just a y1. Obviously, the lower exponent is the plain y. I'm going to cancel that out. And then I do 3 minus 1, which gives me 2. So I'm left with y squared on the top.
Realtor, Real Home Realizations by Realtor.com. I just realized, you know what stage of life.
Please mute yourself. So and then I look with what I'm left with. I am left with a 2 and a y squared on top. So my numerator, my top is 2y squared. In my denominator, I have a 3x squared. So that's my denominator. And my answer has become reduced 2y squared over 3x squared. Hint, if everything crosses out from either the numerator or the denominator, it doesn't mean there's nothing left there. It means it's left with a 1. You're canceling out by dividing, so you must be left with 1. Remember, we had it with the factoring. Same thing here with the reducing. Okay, do you think you're ready to try one on your own?
Yeah.
Okay, so I'm going to give you a problem to try while I take attendance. Okay. I'll leave this problem on the board so that you can see. Um, 45 a cubed b squared c fourth over, let's make it negative 45 just to make it a little more interesting, over 72 a6 b squared c squared. See if you could reduce this fraction to lowest terms. While you're doing that, I'm going to be reading attendance. Azia. Azia. Okay, see, she's here. Nashia. Nashia here? Okay, let's see. Anna Belkis. Does anybody know what happened to her? She hasn't come in a long time. Anybody have any contact with her? Emma. Messiah.
I'm here.
Good. Oh, I'm glad you're here. Were you here on Tuesday?
No, I had overslept.
Okay. I just don't want to make a mistake on I have you absent and I wasn't sure. April.
Present.
Hi. Good morning.
Good morning.
Khadija. Khadija here? Umar. Umar. Yakima. Yakima. I see you're here. Cheryl, I know you're here. Stacy, I know you're here. Natalie, I know you're here. Erica,
Good morning, Professor.
good morning. Jonathan,
Here, I'm here.
yeah, good, thank you. Luke. Luke here? Layla, I know you're here because we spoke before.
Yes, I'm
Ashley.
here.
Ashley,
Good morning.
good morning. Kachira,
Here.
good morning. Jennifer,
Here.
good. Rachel,
I'm here. Good morning.
good morning. Gloria. Corey,
Here.
good. Denisha,
I'm here.
good morning. And Devana, I know you're here. Devana, we were talking before. Okay. I know you're here, okay. Okay. So let's look at this example now and see if we could reduce it. Did anybody see any common factor in 45 and 72?
Yeah, I use 5 and -5 and 8.
Not 8.
8.
How much?
9.
9, right. 45 is -5 times 9. And what is 72?
6 and 12.
Yeah, but is there anything that would, I see there's a 5 and a 9 here. Is there anything that would be similar? Remember, we're looking for common factors. I see
Nope.
Cheryl wrote down 8 times 9.
Okay.
You can use your calculator to reduce the numbers. It won't reduce the letter parts, but it will reduce the numbers. If you would put in -45 over 72, if you have a fraction button on your calculator, it will then reduce it. The 9 is the common factor, and you'll be left with a -5 over 8. Okay, what about, okay, so that takes care of the numbers. Let's talk about the letters. What do I do with the A's?
You look for the common factor or subtract the 3 from the 6.
Right. So the lower one is the 8 to the 3. Remember, we can just cross that one out and subtract 6 minus 3. That'll give me 8 to the 3. And notice the 8 to the 3 is in the denominator because that's where the larger exponent is. You cross out the lower one and you subtract it from the higher one, and your answer is left where the higher one is. What about the b squared? Does anybody have any idea what to do with
They
the
cancel out.
They both totally cancel out because the common factor is b squared, so we can
Mhm.
cancel out both of them. And what about the c's?
You use the 2.
Right, the lower one is the 2 exponent, so I cross that one out, and I do 4 minus 2 is 2, but now that's left in the top because that's where the higher exponent is. Now here you see what I'm saying about things getting messy. So let's
Yeah, I
be
mixed up
careful.
mine.
So on the top, I'm left with a -5 and a c squared. That's all I see left in the top. And on the bottom, I see I have an 8 to the 3rd. So obviously that's much simpler than the whole complicated thing. So this is what we do when we have a monomial fraction. The top is a monomial, the bottom is a monomial. We can reduce it by just finding the common factor of the numerator and denominator. Okay? Now, before I go to these rational expressions that are made up with polynomials, I want to go on to the next step in operations. Once you know how to reduce, it really is quite easy to multiply and divide these fractions. So let me show you how to do multiplication and division with just regular numbers. And then we'll go on to multiplication and division with rational expressions. So let's say I had 10 over 5 times 15 over 2. Let's say I wanted to multiply these two fractions. Well, the basic rule in multiplying of fractions is that you multiply the two numerators together and you multiply the two denominators together. If I were to do that, I would have got 10 times 15, which is 150, over 5 times 2, which is 10. And then I'd have to reduce this fraction, which sometimes, since you've done all this multiplication, might come out to be quite large numbers to deal with.
Can I say something, Ms. Pearl? Sorry to disturb you, but I thought with fractions you can only multiply with if they have the same common denominator. No?
No, that's adding and subtracting.
Okay, sorry.
Multiplying, and dividing, you do not need, that's why I'm doing it first, because a common denominator is harder.
Okay.
That's why I'm doing, with multiplying and dividing, you do not have to have a common denominator.
Thanks.
Okay. All you have to do, really, it's simple. Multiply the tops together, multiply the denominators together, the bottoms, and then reduce. So you get 150 over 10, and I think you could see that 10 is a common factor. If I divide the 150 by 10, I get 15. If I divide the 10 by 10, I get 1. So I get 15 over 1. Remember, when your denominator is 1, you don't have to put it in, and you could just write it, instead of 15 over 1, you could just write it as 15. You can't do this when the 1 is in the numerator, but when the 1 is in the denominator, you don't have to put it in. When the 1 is in the numerator, you must put it in, because 1 over 2 is not 2, but 2 over 1 and 2 are the same. So that's one way of doing it. There is a way though, to make it
Professor, sorry, excuse me. So it couldn't be factored just as it is?
Okay, so I'm just going to
Okay.
talk to you about that.
Okay, sorry.
I'm going to show you what I think is a more efficient way of doing something like this, where instead of doing the reducing at the very end, so where your numbers have become quite big, you can do your reducing before you do the multiplication. How do you do that? You look for any common factor in a numerator and a denominator. Now, it could be in the same fraction, or it could be in the opposite fractions. It just has to be a numerator with a denominator. So if I look at this 10, is there a common factor with anything with a 10 from the two bottoms? Can't be from the 15, because that's another numerator. This is a numerator, I have to find something in the denominator. And actually, I see right away that the 10 over 5, I could have reduced that by dividing the top and the bottom by 5, which would have left 10 divided by 5, which is 2, and 5 divided by 5, which is 1. Now, I usually don't put in the 1 unless there's nothing left in that fraction, in that numerator or denominator. I can't leave a denominator, I can't leave it blank. But if something else is left there, I don't have to put in the 1. But if everything got canceled out, I have to put in that 1. I now see, I could even go further. There's now a 2 in the numerator, and there's a 2 in the denominator. It's not in the same fraction, it's in the second fraction. But remember, I said you could reduce any numerator with any denominator. So therefore, I can divide this by 2. Of course, that'll leave me 1. And this by 2, and that'll leave me 1 as well. Now there's nothing left. Again, you have to be careful, because you have to, when you cross something out, don't scribble it totally out, because you want to be able to see what's underneath. But do cross it out so that you know you're not using it anymore. What I'm left with in the numerator now, since everything has been, this is what's called cross-canceled. We can now multiply the numerators together. 1 times 15, which will give me 15 in the numerator. And the denominator is 1 times 1, which is 1. And remember, we don't have to put the 1 in the denominator. And again, my answer came out to be 15. When the numbers are large, it sometimes makes more sense, What we're doing is we're reducing before we multiply. And we can do this as long as we have any numerator with any denominator. If we have I'm going to go do one run more right here. Suppose I gave you 6/5 divided by 24/35. When it comes to division of fractions, it's really almost the same thing as multiplication. You have to do one step before you get to multiplication. You have to take your second fraction, and if it's not a fraction, if it's a whole number, then you have to put it over 1. What you have to do is you have to take that second fraction and take its reciprocal and change the problem. You leave the first fraction alone, as 6/5, but you change the operation to multiplication by taking the reciprocal. So you
So we
take the
leave-
reciprocal, you flip your second fraction, and then you have a multiplication problem. Okay, I'm going to give you a couple minutes to finish this multiplication. Cheryl, you want to tell us what to do?
Yes, so when you do that now, you just start to cancel by 5 into 5, 1, and 5 into 35 goes 7 times.
Okay, so she sees the 5 and the 35 can be canceled out, the 5 by a common factor of 5. So here we're left with 1, and here we're left with 7.
Then you say 6 into 6 goes 1, and 6 into 24 goes 4 times.
And she saw again the 6 and the 24 have a common factor of 6. So
Yeah.
again, any numerator with any denominator, it can be in the same fraction, it can be in the next fraction.
We
And
have
then
7 over 4.
So 1 times 7 gives you 7,
7.
and 1 times 4 is 4.
is
This is what you often call an improper fraction because the numerator is greater than the denominator. But in algebra, there are no improper fractions. The best way to leave a fraction is this way, not as a mixed number. Don't change it to a mixed number. Leave your answer 7/4. Okay, I'm going to give you one like this to try. I'm going to see if you can do it on your own. That has letters in it. That's a rational expression. Can I erase this now? Anybody still need it? Okay. So let's say I gave you this problem. It's 11a squared b over 5ab squared divide by 22 1/3 b seconds over 10 ab fourth. Okay, I'm gonna give you some time to try that. Okay, I think we have enough time. Let's go through this. I see it's a division problem. That means I'm going to rewrite this by changing this to a multiplication and flipping that second fraction. So this will become 11a squared b over 5ab squared times 10ab fourth over 22a third b squared. And I'm going to start, what I'm going to do is because there's so much to do here, I'm just going to go through the top and see if there's in any number or letter, can I match it up with something in the denominator so that I can cancel it out? So I have an 11 here. I see there's a 22 in the denominator, and those can be canceled out. So I'm crossing out the 11. I don't have to put the 1 yet because I still have some letters here. So I'm not totally blank. And here the 11 into 22 gives me 2. Then I look at my a squared. Is there any a place that I can cancel out an a squared in the denominator? And I see there's an a third in the denominator and a squared here. I can cross out the one with the lower exponent, which is a squared, and subtract the higher exponent. 3 minus 2 is 1. So this will give me an a to the 1, which is just a plain a, again, in the denominator, because that's where the larger exponent was. Then we have a b. Is there any place I could cancel out the b? Now, I can do it either with this b squared or with this b squared. Let's do it with this, because it doesn't make a difference, so let's do it with this one. So I'm going to cancel out this b, and that's the lower exponent, so this becomes 2 minus 1, which is 1, which is just plain b. Notice, now this whole numerator has been canceled out. Now I put a 1 there, because if everything is canceled out, I have to put a 1 in place of it. Let's go on to the next number I see, which is a 10. And in the denominator, I see there's a 5. I can cancel out this 5 with the 10. So the 10 divided by 5 is 2. The 5 divided by 5 is cancels out. But now I have a 2 here and a 2 here. I can cancel out. It doesn't only have to be in the other fraction. It could be in the same fraction. I can cancel out this 2 with this 2. Now I go on to the B's, to the A's. There's an A here. Is there any A I can cancel it out with? And I could do either one, but let's say this A and this A gets canceled out. Remember, they both have the same exponent, so they just get totally canceled out. And the B fourth, well, first I see a B squared and a B fourth, so this will leave me the B squared canceled out, and the 4 minus 2 is B squared. But now I have a B here and a B squared here. I can cancel out this B, leaving this to be 1. And 2 minus 1 is 1. So this is just a plain B. So that in my final answer, I have 1 times B, everything else canceled out in the numerator, over 1 times A. So my final answer became B over A.
Professor, could you go over that one more time, please?
Yeah. Should I erase it and start all over again?
Yeah, you could.
Can I, if I can say something really quickly, I thought for me, what I would do is I wouldn't reduce it for me. I would just multiply it across.
You
that's how I
could
get
do it that way. You could do it that way. Do you want me to do it that way and then reduce it?
I guess, yeah, you can.
Okay, let's try it with Jonathan's. He said, instead of doing this, all this interim, and again, both ways work. So I'm going to show you that method as well. So let's do it by Jonathan's method. What he did is, he did by what we did the first time. We Of course, we have to change this to 11a squared b over 5ab squared times 10ab to the fourth over 22a third b squared. So this is an alternate method to do that. Either you can first reduce and then multiply, or you can multiply and then reduce. So Jonathan wanted us to multiply first. So that means multiply the numerators together. 11 times 10 is 110. A squared times a, remember when we're multiplying, we add exponents. That gives me a to the third. B times b fourth is b fifth. And in the denominator, he did 5 times 22, which is again 110. A times a squared is a fourth. And b squared times b squared is b fourth. Okay, and now he said, now we're going to reduce this one. And I happen to agree with you. In this case, this one was the easier way to go.
Yeah.
The 110 on the top cancels out with 110 on the bottom. The a third and the a fourth, the a third cancels out. 4 minus 3 is 1. So this becomes a on the bottom, a to the 1, which is just a. B fifth and B fourth, the lower one is the B fourth, so we cancel that out. 5 minus 4 is 1, so we get B in the numerator. So again, we get, of course, we get the same answer, B over A.
Professor,
Yes.
how do we know when to put, when we divide the letter or number, how do we know which one to put on top
Okay.
and which one to put on bottom?
Okay, so here's you cross out the one that has the smaller exponent, and you subtract that smaller exponent from the larger exponent, and your answer gets left where the larger exponent is. In other words, there was a B5 here and a B4 here. So the B4 is a lower exponent, that gets canceled out. The 5 minus 4 is 1, so the B gets left in the top because that's where the larger exponent is. Does that explain you?
So we put the letter or number where it's the larger exponent.
Notice with the A's, there was an A third on top and an A fourth on the bottom. The larger exponent was on the bottom, so that's why the A ended up on the bottom.
Okay, I get it.
Okay. So cross out the the one with the lower exponent, and subtract the exponents and put it where the larger exponent was. Okay, now.
Professor,
Yeah.
Omar want to get in the class. Omar Diallo.
Where is?
No one's in the waiting room.
Melissa's letting him in. Okay. Okay, so I just want to go on to one more topic. I'm not going to do okay. One more type of example, and then I'll do some review. Okay, I'm going to erase this. What happens if I have this fraction that looks like this?
Professor, your mic is muted, I think. Yeah, I can't hear you.
Me, I don't know why I am.
Now we can hear you.
Oh, okay. It was Melissa muted, probably muted everybody, so then I got muted as well. Thank you. So we have this fraction that isn't a monomial over a monomial. It happens to be a polynomial over a polynomial. What happens when my fraction consists of polynomial? I'm just going to do one problem like this because I want to have some time to review. But this will take us into the next topic. We'll continue with this tomorrow. The concept is the same. We want to try and reduce our fraction by finding a common factor in both the numerator and the denominator. But when we're finding common factors when we have polynomials, we have to do polynomial factoring. We have to do the factoring the way we have been doing it in chapter 4. And after we've completely factored our expressions, then we're going to compare them and see if there's anything alike that we can cancel out. So so this involves quite a bit of work, because first we have to factor the numerator, and then we have to factor the denominator. Okay, remember when we're doing the factoring the numerator, we figure out what our AC is, because this is a trinomial. 1 times 15 is positive 15. So I need to take this, look for numbers that multiply to 15, and they're both going to be negative because since it's a positive 15, both signs have to be the same. And they're both going to be negative because my middle number is negative. So what numbers multiply to 15, but when we add them, give me 8?
Negative
I
5,
think we
negative
all 5 and 3. So we'll break this into negative 5 and a negative 3. Of course, put our x's next to each of them. So this will become x squared minus 5x plus 15, which I'm going to then factor into x times x minus 5. And over here, since I'm starting my second group with a negative, it's going to be a negative 3 times x. Negative 3 into the positive 15 gives me negative 5, which then we could write as x minus 5 and x minus 3. So my numerator factored into x minus 5 and x minus 3. Let's see what we do with the denominator. In the denominator, my AC happens to be 1 times negative 10, which is negative 10, which means one of the numbers is going to be positive and one of them is going to be negative. And I need numbers that multiply to 10, but when I subtract them, they'll give me 3. So obviously that's 5 and 2. And it's the 5 that's going to be the negative one because the larger one is going to have to be negative. And the 2 is going to be the positive. Here are my x's that I put next to it. Here's my x squared. Here's my negative 10. And this is then going to be x times x plus 2. And my next one has a negative 5 as a common factor. That becomes x plus 2 as well. So the denominator factors into x plus 2 and x minus 5. All the hard work has now been done. The hard work is do the factoring. Once the factoring is done, we can then look, and it's going to, when it's polynomials, it's going to be very easy. You look for identical polynomials, identical binomials. There's an x minus 5 on the top. There's an x minus 5 on the in the denominator. The binomials have to be identical in order to cancel out, to be a common factor. There's a common factor of x minus 5. Notice I look for the common factor after the thing is totally factored, so that my final answer comes out to be the x minus 3 in the numerator and the x plus 2 in the denominator. You cannot cancel out these x's. You can't cancel out terms. You can only cancel out factors, parentheses. The only time you have only monomials. There's no pluses or minuses. But once you have pluses and minuses, once you have multiple terms, you've got to take each thing as a unit. So here's how we do it. We are going to, that's what we're going to continue with next time. We will,
Professor,
in a way, the hard work is the factoring, but once you have the factoring, it's really easy to see what to cancel out. Yes, question.
Professor, could you go over it one more time, please?
Yeah. Are you okay with the factoring? Can I just go to the, are you okay with how I got the factors?
No,
Okay,
I'm a little bit confused there.
okay. So I'm gonna erase it and start from scratch. Because the factoring you have to know for the midterm anyhow. So let's do that. I'll do each one separately, instead of trying to do one on top of the other. Okay, how do we factor x squared minus 8x plus 50? How do we break it up? If you remember, what we do is we multiply, we do the AC method. The A here is 1, the C is 15. My AC is positive 15, which means I'm looking for two numbers that when they multiply, they're going to give me 15. And since this is plus, when they add, they're going to give me 8. Do you see that those numbers are 3 and 5?
Yeah, -5 and +3.
So this becomes x squared minus negative 5x plus, I'm sorry, they're both negative, minus 3x plus 15. Okay, so that when I factor, my common factor here on the first two is x, so that becomes x times x minus 5. And in my second group, I have -3 as my common factor, and -3 into -3x is x, and -3 into positive 15 is -5. So x minus 5 is my common factor. So this becomes x minus 5 times x minus 3. You okay with that?
Yes.
Okay, so I'm putting that on top. My top became x minus 5 and x minus 3. Okay, can I erase this?
Yeah.
Okay, so let's go to the denominator. You'll see all the hard work has to do with the factoring. If you're good at factoring, it's easy. If you have finding factoring harder, it's going to be harder. In the second one, my AC in that case is 1 times -10, which is -10. Since it's negative, we know that we're looking for two numbers that when we multiply them, they're going to give me 10, but when I subtract them, because this is a minus, so we're going to have to subtract, we're going to get 3. So what are those numbers?
-3 and +2.
Why is that not a good choice?
No, that's where I went wrong.
I need them to multiply to 10.
5 and 2.
5 and 2 are the numbers, and which is going to be the positive and which is going to be the negative?
The 5 will be the negative and the 2 will
Right,
be the
because
positive.
the middle term is negative, so it'll be a negative 5x and a plus 2x. I just worry about, should I be adding the two numbers or should I be subtracting the numbers? That's how I think about it. This is x squared, this is negative 10. Okay, so in my first group, my common factor is x, so that becomes x minus 5. And in my second group, my common factor is 2. So that gives me 2 times x minus 5. So my common factor now is x minus 5. So I go x minus 5 and x plus 2, correct? And
Yeah.
so here's my next. This, I've done all the hard work. Now I just look, is there anything identical from the numerator and the denominator? Is there any identical binomial?
X.
Is there any binomial that's exactly the same in the numerator and the denominator?
X5. X
Yes.
minus 5.
5. There's an x minus 5 on top and x minus 5 on the bottom. That is our common factor. That's what gets crossed out. In a way, it's easier than those monomials where you have to take each thing apart. Here, you don't have to take it apart. It's each thing is a unit, and you just cancel out a unit. And of course, that leaves your answer as x minus 3 and x plus 2. Is that clear now?
Yes, it is.
Okay. Okay, let me see what we have on our chat. Okay. All right, so now this is where we're going to be continuing tomorrow. We have about 20 minutes left of class. I want to ask you, is there any topic that you would like me to review from chapters 1, 2, or 3?
The graphing.
The graphing. What part of the graphing? How to graph a line or how to write the equation of a line?
One will be finding the slope and how to graph the line.
One is to find the, I'm sorry. The
Slope of the line.
Okay.
Yeah.
Okay. So let me see if I can give you a problem similar to what you might be expecting. What if, so there, when they ask you to write the equation of a line, they want you to write something in the form y equals mx plus b, unless they specifically say in standard form, but usually we want our answer in what we call the slope-intercept form. So the question is, how do we find the slope of the line? And it very much depends on the information that we're given. Sometimes we're given 2 points on the line. Then we have to use a slope formula. Sometimes we said something like it's a parallel to a different line or it's perpendicular. Talking about parallel or perpendicular also is a hint towards the slope. Let's take an example though, where they give us 2 points. Let me see if I can find an example. Okay. Let's say I gave you these 2 points, -7, -6, and -4 and 9. Okay, here's the question. Find the equation of a line through the pair of points. Okay? We want to write the equation of the line between these 2 points. Then we're going to talk about how do we graph the line. Actually, when we have 2 points, it's really not hard to graph. You just plot each point and then connect the two points. So how are we going to find the first thing, which is the slope? How do we find the slope of the line? So we know that the formula for the slope is y2 minus y1 divided by x2 minus x1. Whenever we are given 2 points on the line, we use the slope formula to figure out its slope. Just put one of the points as x1, y1, and then call your second point x2, y2. So then your slope is going to come out to be 9, that's your y2, minus -6 over x2, which is -4, minus -7. Now you have to be careful, especially when they're negatives. You have to be very careful with these numbers. Remember, this is 9 minus and minus becomes a plus, so it really becomes 9 plus 16, which is 15. And this is -4. Again, here's my minus and minus, so it becomes a plus. -4 plus 7 becomes 3. And we can reduce this fraction, 15 over 3 reduces to 5. Now, when we want to use the slope to graph with, we usually write it as a fraction. But if it's just writing the equation, we can leave it just plain 5 instead of writing a 15 over 3 or 5 over 1. We're halfway to our solution. Our equation has now become y equals 5x plus b. What we don't have is the b. Whenever we look to write the equation of a line, we work on the slope first. How am I going to figure out what the b is? That's where these points come in. I can take either one of the points. I'll take the first one just because it doesn't make a difference, and substitute it in. In other words, I can put in place of the x -7 and in place of the y -6. Alternatively, I could have put a -4 in place of the x and a 9 in place of the y. Be very careful. Don't mix and match. The x one has to go with the y one. You can't take the x from here and the y from there. Okay? Substituting in these numbers, I get -6 equals 5 times -7, which is -35, plus b. And then I add 35 to both sides, which will give me that b equals -6 plus 35, which is +29. So my final answer becomes y equals 5x plus 29. Stacia, does that help you?
Yes, Professor.
Do you want me to show you how to graph it on the, that's not, truthfully, on the midterm, as well as on the final, on those Blackboard tests, you're not going to have to do those things that you have to do on Delta Math. There'll be pictures and you will have to pick the correct picture. Sometimes they do that, but they never ask you to actually do those graphings like the way you have to do on Delta Math.
Okay.
Okay. Is there anybody else who has a question?
Yes, I have a question. I wanted to know if you could reopen the homework for number 11.
Sure, it's not open?
I don't think so. I'd have to check.
Because usually on the homeworks, I give an initial date. And then and then there's a late date, which is someplace in May.
Oh,
So
all right.
try it.
I'd have to check.
What?
I'd have to check. I'd have to check. If
Okay.
anything, I'll email
If
you.
you still run into problems, just,
Mhm.
and if you have a good reason for why it's late, I'll just excuse the late and I'll change it.
Okay, that'll be
You should
fine.
be
Thank you
able-
so
you
much.
should be able to get in.
Okay, thank
Corey, I see, oh, that says nothing. You wanted me to do a system of equation? I see there's a bunch of stuff on the. Corey, I see did you want me to do something with the system of equations? You could,
Professor, can you go over substitution?
the method of substitution using a system of equations, sure.
I was asking about the when Cheryl mentioned word problems, if she was talking about the system of equation problems.
Okay, so. And for tomorrow, I'm going, every day and Tuesday and Thursday of next week, I'm going to leave the last part of class to go over any questions that anybody wants to go over. So think of anything that you'd like me to do. Of course, you have Melissa, who's doing a very good job of reviewing as well. Okay, so let's take an example. Let me see if I can find an example that would be good with substitution. Okay, suppose I gave you something like this. X equals 4y minus 3 as one equation, and I don't want to do that one because that one's going to run into problems. Let me do this one. X equals 4y.
Professor, I'm gonna have to get off for a second because I have like a tech coming to check out my internet because I've been having issues with it.
Equals -6. Let's say I give you these two equations.
Corey said he had to step out because he had issues with his internet. Is she frozen?
Yeah, she want to say anything to me?
Yeah, he was letting you know
I
that he.
can't hear what you're saying.
I was trying to let you know that I'm gonna leave out because I have a tech coming over because I've been having trouble with my internet where it just like randomly cuts off. So they're like here to check it out.
Is she frozen?
Jennifer, you have a question? Is this something you want to say to me? Am I losing you?
No, he was saying that he has to leave because he had to fix his internet with the tech. He had to leave because of his internet. Ooh.
She lost connection.
Now I hear, are you back?
Just read the chat because he texts in the him and Jennifer checks it what's going on in the chat.
Professor,
Yes,
did you read it?
I hear you now. You hear me?
So yeah, so he had to leave because his internet was
Oh,
acting up. Yeah.
no problem. I didn't realize, you don't have to tell me. Mine was, as much as I rebooted and everything, things were pretty good until now. I don't know why.
Yeah, yours is going in and out too.
Yeah.
I'm losing you again. You know what? We'll do this tomorrow. Okay? I'm gonna leave. Melissa, can you do that problem with them?
Sorry, what you said? Hello?
I'm gonna leave it because I'm running the problem. I keep getting strange messages. Okay,
hear you.
okay, Melissa, can you do this?
The problem that's on the board?
Yes. I'm gonna leave because I'm keep getting, I'm getting, that my bandwidth is not good enough or whatever.
Okay.
Okay, so I will see you tomorrow, everybody. Have a good day.
Bye. Have a good week. Have a good afternoon.
Yeah, we'll see you tomorrow. Bye-bye.
Okay, bye.
Bye.
Bye, Professor.
Bye-bye.
Can somebody drop the question in the chat? I didn't get to see it.
Did someone write the equation?
I was telling her to wait so I could write it down. She left. No one got the question? Okay, I know it was a system of equation problem, so I guess I could make, it's not gonna be effective. Let me see something.
Yeah, it was a substitution one.
Oh, substitution, so something like, say for instance, see if I can text it. Say if you have like 3x plus y equals 15. Something like that, right? is a substitution problem, right? So with a substitution problem, majority of the times, they will have like one of the problems not having like a number to the variable. Let me say that again. So like you see how you have 3x plus y is equal to 15? This y doesn't have a number, right? But 4x plus 9y equals 30. So these have numbers, right? You might get a decimal because this is something that I worked out, made up, but the concept still applies, right? So the substitution, instead of like trying to work everything out at once, like with a system of equation, what you could realize is that if you turn this problem by just finding y, you realize that, okay, 3x plus y is equal to 15. You're basically solving for y because that's the only one that doesn't have a variable. Right, so I'm gonna subtract . So that means that y now is equal to negative 3x plus 15, right? So if y is equal to negative 3x plus 15, you can now substitute y into this problem. So you have 4x plus 9, but instead of putting y, you're putting negative 3x equals 30. Everybody get what I'm doing so far, right?
Yeah.
All right, cool. So first thing I did was solve for y, and then now I substituted back into the second equation. And then I'm now gonna just solve. And be 4x. So 9 times negative 3x plus 9 times 15
135.
is equal to 30, right? Then these are like terms. So that's gonna be negative 37x. We're trying to find y, sorry, x. So yeah, subtract 135. Subtract 30. So X is equal to positive 4 point. As I said, it's not gonna be a whole number because I really just made this up. But the concept still applies. Everyone got 4.56. After you divide negative 105 into 23, or 23 into 105. Yeah,
Can you repeat that again?
which part?
No, what you just said.
So when you divide negative 23 into 105, you got 4.56, 56, that's the same.
Yeah.
Oh, so that's your X, right? But now to find your Y, you can plug it into any one of these equations, right? So personally, I'm just gonna plug it into the first one because it just makes it a little easier. So now we have 3, but since we have X, you're gonna plug it into the 4.56 plus Y is equal to 15 times. So this is gonna be 13.69 plus Y is equal to 15. Subtract 13.69, subtract 13.69. So Y is equal to 1.30. Everyone got 1.30? Okay, let me check again. Yeah. All right. Anybody have any questions with this?
No.
All right, cool. I'm actually gonna end the call early today. My head is hurting. So like if you have like any questions or anything like before the test or anything like that, we can definitely pick it back up for tomorrow. Because remember, I do like extra hours. I could stay from 1 to 3 tomorrow. So like, you know, definitely utilize that. But today I'm gonna just end the call early today. So anybody have any questions before I go?
No.
Have this worded problem.
All right, Shirley, you can text me and
All
I'll
right then,
not text
yes.
me, email me,
All
and I
right.
got you.
All right then, no problem. Thanks.
No problem.
Yeah, thanks. All right.
Anybody else?